Alright, so with this one, um, again I showed you the graphical approach with Desmos on the other video, but if I move this, this should be a cubed, sorry. If I move the 64 to the other side, I have this. And so this I can probably factor. I could factor an x squared out of that first bunch, and I could factor out, looks like to be a negative 16 out of the second bunch. So I could see x squared minus 16 times x plus 4 less than or equal to 0. Well, when we're doing this, we could set each piece equal to 0, and that would give us some places to check. This part would give us x plus 4, x minus 4, equals 0, and that piece is easy enough. So we need to look around 4 and negative 4. And on the graph we saw at negative 4 it was equal to 0, but then it came back down. So all those values. That just gives us places to check on our number line. So if we checked a point somewhere in the middle, let's just say 0. If I were to plug 0 into this original equation for x, is it true? So 0 plus 0 minus 0 is a whole bunch of zeros. Is 0 less than or equal to 64? Absolutely. So we could say that these are, this one's true. So that would be a good area. We could check somewhere over here, let's say negative 5. Oh geez. So if I'm plugging negative 5 in for my x's, is this true? Negative 5 cubed is negative 125 plus 4 times 25 would be 100 minus 16 times 5, which would be minus 80. So if I added all those up, I get some negative number. Is a negative number less than or equal to 64? And it is totally less than. So to the left over here, those values work. Now if I went to the right of 4, let's say 5, let's check those out. So I get a positive 125, a positive 100, and then a, oh, the last one, it was negative 5, that should have been a positive 80. Oh, now I gotta check that last one. So when we used negative, when I used negative 5, I would get negative 125, positive 100, and then a positive 80. So that's 180 minus 125. That would give me a 55. 55 is still less than or equal to 64. So we are still good with checking this one. Okay, back to checking 5. When I check 5, I get positive 180, 125, positive 100, and then negative 80. And if we add those up, 225 minus 80 would give us 145, and 145 is larger than 64. So over here, these values do not work. So that helped us figure out that I need to go from negative infinity to positive 4. Because this area was good, this area was good, that area bad. The next one that we had was number 4, and it had that rational expression. So it was 5 plus 3x over 1 plus 2x is less than or equal to 2. So I went ahead and I subtracted. I don't know if that would be the easiest way to do it, but we're going to do it anyway. 1 plus 2x, and I'm going to subtract 2. Well, when I subtract 2, they don't have a common denominator. So we're going to make them have a common denominator by multiplying top and bottom by 1 plus 2x. Because I subtracted the 2 over, I have 0 on the right-hand side. So now, what I'll have is 5 plus 3x minus 2 minus 4x all over 1 plus 2x less than or equal to 0. Well, this thing's going to be equal to 0 when that numerator is equal to 0. So when I look at that, this will find one of our values. I get 3 minus x is less than or equal to 0. And then subtracting 3, and then dividing by negative 1. Make sure you flip your equality sign when you divide by or multiply through by a negative. I get x is greater than or equal to 3. And that's something that we had seen was an answer. And so that would take me from 3 to infinity when x is greater than or equal to 3. Now, we also had those values when it was to the left of negative a half. So we have to look also around our vertical asymptote what's going on. So when you think of your number line, we're going to check negative 1/2 and 3. Those are kind of the values that showed us something. When I check 0, right, to see if it makes it true, let's go back up here. When I plug in 0 for x, I get that would go away and that would go away. So I get 5 is less than or equal to 2. Well, that's not correct. And so it wouldn't be this part. And then we could check the left of negative a half, so maybe negative 1. And if we plug negative 1 in here, I think we'd get a 2 up top and a negative 1 on bottom. So that would be a negative value is less than 2, so that side would be good. And if we pick greater than 3, let's just say 4, that would also give us something that was less than or equal to 2. So that would be good. So that's why we went from 3 to infinity, and also negative infinity to negative 1/2. We did not include negative 1/2 because that was a vertical asymptote.